This is the homework 2.C.4e. It's actually two sets of 3 questions, starting with 1010. We're supposed to find the shapes of the molecules. So if you draw out their Lewis structures, determine how many electron domains there are, and how many of those electron domains are either single or double or triple bonded atoms. Then you can determine the shapes. The first one, 1010A, CH3I is tetrahedral because carbon has 4 sets of electrons and they're all atoms. ClF3 is T-shaped. The center atom chlorine has 5 sets of electrons. Only 3 are atoms, and so that makes a T-shape. H2S is bent or angular. Letter C, 4 sets of electrons, 2 of them are atoms. SO3, actually the best picture of SO3 is not 1 double bond and 2 singles, but 3 double bonds. And SO3 with 3 sets of electrons will be trigonal planar. SO4, 2- has 2 resonance structures with different locations for the double bonds, but with 4 sets of electrons, the shape will be tetrahedral. 1012 is another one with shapes. NH4 plus, tetrahedral, 4 single bonds and no lone pairs. NH2 minus bent, 2 lone pairs, 2 single bonded H's. Carbonate has 3 possible Lewis structures, depending on where you put the double bonded oxygen. But it has 3 sets of electrons, so it's trigonal planar. ICl2 minus is going to be linear with 3 unshared pairs in the equatorial positions of a trigonal bipyramid. But the atoms are at the poles and the middle, and so it's linear. ICl4 minus is square planar, 2 extra lone pairs on the center iodine. Letter F, AlH4 minus is tetrahedral, and SnCl5 minus is trigonal bipyramidal. The H3O plus ion, hydronium, is trigonal pyramid, 1 lone pair on the O. And BeF4 2 minus, the attachment of 4 fluorines and having those extra 2 electrons, beryllium does not need to have 2 pairs, it can have 4, and so it's tetrahedral. Okay, 1020 asks why. Actually, I think I skipped over 1014. SiCl4 tetrahedral. Ci4 is tetrahedral also. CdCl4 2 minus is tetrahedral. So those would be the examples that are tetrahedral. SeF4, even though it has 4 atoms, does have 1 unshared pair, and so it's sawhorse. And xenon tetrafluoride is square planar with 2 unshared pairs. 10.20 asks why the trend is for HF to be most polar and HI to be least polar. It has to do with differences in electronegativity. H and F have the greatest difference in electronegativity, and it follows then from HCl to HBr, and then HI has the least difference in electronegativity and is least polar. OCS and CS2 actually have very similar structures. There will be carbon with linear shape and double bonded oxygens and sulfurs. However, since O is more electronegative than carbon and more electronegative than sulfur, in OCS you will have the left side of the molecule, as I've drawn here, will be linear. The left side will be linear, and the left side will be negative, the right side will be positive because of the difference in electronegativity between O and S. And so OCS is a polar molecule, whereas CS2 will be linear, and any polarity that would happen between the carbon and sulfur bonds is going to cancel out and give you an overall nonpolar bond, nonpolar molecule. And 1024, looking at these various pictures of benzene rings with 3 chlorines on them, or 2 or 3 chlorines on them. B and D, if you look at their geometries, are symmetrical and would cancel out. In C, you have 2 opposite chlorines that would cancel and only one other chlorine that doesn't have anything opposite to cancel it. So C would be a little bit polar. And then A would have 3 chlorines on the top half of the molecule and none on the bottom. And so it would be the most polar based on the shape.